Hey y'all, today is Monday, August 23rd, and we're going to go over a few extra notes that I have prepared to help us with lesson 1-2 coming up this week. We're first going to talk about reducing fractions to simplest form. So let's look at number 1. We have the fraction 16 over 40. What I recognize right off the bat is that those are two even numbers. So I know that I can divide them both by 2. So I divide both the top and bottom by 2. Whatever I do on the top, I must also do on the bottom. So 16 divided by 2 is 8, and 40 divided by 2 is 20. Okay, now I recognize again that I still have even numbers. So I can divide both my top and my bottom by 2. So divide 8 by 2 and 20 by 2 as well. 8 divided by 2 is 4, and 20 divided by 2 is 10. Okay, our numbers are getting smaller, but 4 and 10 we know are also even numbers. So I'm going to divide by 2 again on the top and on the bottom. 4 divided by 2 is 2. 10 divided by 2 is 5. So now I'm left with an even number on top and an odd number on the bottom. So I know I cannot divide these both by 2. In fact, there's not a common number that goes into both of them together. And because of that, I know that I have reduced our fraction to simplest form. So 16 over 40 is equivalent to 2/5. Now, we divided by 2 3 separate times. We divided by 2 here, here, and here. Would I have been able to divide by 8? Yes, I would have. I know that 2 times 2 times 2 makes 8. So I could have said 16 divided by 8 is 2 and 40 divided by 8 is 5. So I could have done this in one step. That's easier to do if you know your multiplication facts. If you don't, you can do it step by step. It does not matter how you get to the end result. Okay, moving on. We have 6 over 30. So I recognize that I've got two even numbers right off the bat, but I also know that 3 goes into both of these numbers. So could I start by dividing by 3? Yeah. So I'm going to divide, sorry y'all. I'm going to divide by 3 on the top and bottom. I know that 6 divided by 3 is 2, and 30 divided by 3 is 10. So now I have 2/10, but what I recognize about that is those are both even numbers, and I can divide them both by 2. So 2 divided by 2 gives me 1, and 10 divided by 2 gives me 5. Well, 1/5 is as simple as it can be. If I ever have a 1, I know I cannot keep reducing my fraction. So we know that 6 over 30 equals 1/5. Now notice here, we divided by 3 the first time and by 2 the second time. We know that 3 times 2 is 6. Would I have gotten the same result if I divided both my top and bottom by 6 in the first step? Yes, it would have just saved us that middle step. We would have still gotten to 1/5. Okay, let's look at number 3. So 20 over 70. Well, what I recognize is that both of these numbers end in a 0. So one thing that I can do in this case is cross out those zeros. So that's essentially like dividing by 10. So I've already divided by 10, and now I'm left with 2 7s. Can I reduce that? No, I cannot reduce that. So I know that 20 over 70 is equivalent to 2 7s. And again, one number there is an odd number, the one on the bottom, and the one on the top is an even number. So there is not a number that I can divide into both of those. Moving on to number 4. So we have 24 divided by 110. So I recognize right off the bat, even numbers. So because of that, I'm going to divide by 2 on the top and bottom. So 24 divided by 2 gives me 12, And 110 divided by 2. Well, I know that 100 divided by 2 is 50. So 110 divided by 2, 10 divided by 2 is just 5. So 110 divided by 2 has to be 55. And if I wanted to double check that, I can just come over here and show my work. 110. 2 goes into 11 5 times. 2 times 5 is 10. 11 minus 10 is 1, and I bring down that 0. 2 goes into 10 5 times. 2 times 5 is 10, and there is no remainder. So notice we get 55. So now we have 12 over 55. I want to ask myself, is that in simplest form? I notice that we have an even number up here and an odd number down here. But maybe 3 goes into both of those. Do you know your trick for finding out if a number is divisible by 3? If a number is divisible by 3, the digits will add up to a number that's divisible by 3. So, for example, 12 is divisible by 3 because 1 plus 2 equals 3. Well, 5 plus 5 equals 10, and 3 does not go into 10 an even number of times. So, 55 is not divisible by 3. In fact, these two numbers do not have any common factors. There's not a number that goes into both. So, this fraction is now in simplest form. Okay, number 5, 24 over 27. Remember that trick I was talking about for finding out if something is divisible by 3? Let's use that trick. What is 2 plus 4? Well, 2 plus 4 is 6, and 6 is divisible by 3. So I know that I can divide 24 by 3. Let's see if I can do the same with 27. Well, 2 plus 7 is 9, and 9 is divisible by 3. So I can also divide 27 by 3. So I'm doing the same thing on the top and bottom. Now, how many times does 3 go into 24? We know that 3 goes into 24 8 times. And how many times does it go into 27? It goes into 27 9 times. So 8 ninths. I cannot reduce that any further, so that right there is our fraction in simplest form. Okay, let's talk now about converting fractions to decimals using long division. And I want you to understand what this word convert means. It means change. So we are changing our fractions from fractions to decimals. And we're going to use long division, which I know you have used for years and years and years now. So let's start with number 6, 29 over 40. I first want to go over some vocab with you. So first, I want you to know that that number on the top, that's always called a numerator. The number on the top is always called a numerator. And the number on the bottom is always called a denominator. So, in order to change this from a fraction to a decimal, we're going to use long division. That's the process. But my first question is always, 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 can I reduce or simplify this fraction? And when I look at 29 over 40, one of the things that I notice is that I have an odd number on the top and an even number on the bottom. So things aren't looking so good for me when I see that. I know that 2 plus 9 equals 11, so 3 doesn't go into that. So not divisible by 3. It doesn't end in a 0 or a 5, so it's not divisible by 5. So I'm really thinking that I really can't reduce this fraction. Okay? So, and we actually have the answer there, or nope, we did not. Can I reduce this fraction? No, we cannot reduce this fraction. So, because we can't reduce this fraction, we're going to place the numerator inside the division bracket with the denominator outside. So that's what you see right here. We place the top number inside that division bracket, and we place the bottom number on the outside. Okay, so now we're ready to divide. And I want to point out that we have this division bracket. This division bracket is this funny looking thing right here. Okay, and our quotient is going to be our answer, and our quotient will end up being on top. Okay, so the first question I'm going to ask is, can 40 go into 29? And that answer is no. So I'm going to add a decimal. And a 0. So I'm going to come back up to our division problem up here. I'm going to go ahead and add a decimal and a 0 right here. Now, because I put a decimal right there, I'm going to put one directly above it in my quotient line. Okay, so now I'm going to ask, can 40 go into 290? And that answer is yes, of course it can. So I'm going to have to think about some math right here. But I know that 4 times 7 would be 28. So I know that 40 times 7 is going to be 280. So I'm going to use 7 right here. So 40 times 7 we know is going to be 280. And I'm going to subtract that. Now 290 minus 280, that's going to give us 10. Okay, but we don't want to have that remainder. We want to keep working until we get to a remainder of 0, if possible. Okay, so what we've done, can 40 go into 290? Yes, 7 times. Now we've subtracted. We've already done that. That's our next step. Always subtract. And keep working until the decimal either ends or repeats. Sorry, y'all. Okay, so we subtracted and we got 10. Now that we don't have a repeating decimal and it hasn't ended yet. So what I'm going to do is I'm going to add another 0. And I'm going to bring that down. So now I'm going to ask myself, how many times does 40 go into 100? Well, we know that 40 times 2 is 80, which is less than 100. Now I'm going to subtract that. 100 minus 80 is 20. So now I'm going to add another 0 because we're not done yet and bring that down. How many times will 40 go into 200? Well, I know that 4 times 5 gives me 20. So I know that 40 times 5 must be 200. And I can prove that 5 times 0 is 0. 5 times 4 is 20. So 200 minus 200 is 0. Because I have 0 here, I know that this decimal ends. So our decimal equivalent for 29 over 40 is 0.725. Let's keep practicing. So for number 7, we have 21 over 30. First question, can I reduce this fraction? Well, I know that I've got an odd number and an even number, so I can't divide by 2. But I also know that 2 plus 1 is 3, so I can divide by 3. And 3 plus 0 is 3. I can also divide that one by 3. So I'm going to divide the top and bottom by 3. 21 divided by 3 is 7, and 30 divided by 3 is 10. Okay, I cannot reduce that any further, but with these smaller numbers, it'll be easier for me to divide and use long division. So remember which number goes inside your division bracket. That's right. The number on top goes inside the division bracket and the number on the bottom goes outside. So can 10 go into 7? Nope, it can't. So I'm going to add a decimal and a 0. Don't forget to put the decimal in the quotient line. Now, can 10 go into 70? Yeah, it can go into 70 7 times. 7 times 10 is 70. When I subtract, I get 0. So this decimal ends. Our quotient is 0.7 or 7/10. Okay, moving on to number 8. Okay, so I've got 36 over 90. So I know that these are both even numbers, but let's try our threes trick. 3 plus 6 is 9, so that is divisible by 3. And 9 plus 0 is 9, but that's also divisible by 3. So I can divide by 3. 36 divided by 3, I know is going to give me 12. And 90 divided by 3 is 30. So I have 12 over 30. These are two even numbers, so I can divide both of these by 2. 12 divided by 2 is 6, and 30 divided by 2 is 15. So 6 over 15. We're getting really close here. But I still know that I can reduce these. 3 goes into both of these numbers. So I'm dividing by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. So I get 2/5. So this right here is what I'm going to use to do my long division. And it just makes life easier when I'm working with smaller numbers. So remember which number goes on the inside and which number goes on the outside of this division bracket. The top number goes inside and the bottom number goes outside. So can 5 go into 2? Well, no, it cannot. So I'm going to add a decimal and a 0, but don't forget to put that decimal in that quotient line. Now, how many times does 5 go into 20? It goes into 24 times. 4 times 5 is 20. There is no remainder. So this decimal ends, and our answer is 0.4 or 4/10. Okay, moving on to number 9. This one's different because it's a mixed number. That's what we call this. We have one whole unit and then part of a second unit. So we have 1 and 7/8. So when I face a mixed number like this, I like to just focus on the fraction part. So we're going to figure out what is the decimal equivalent for 7/8. Okay, now I cannot reduce that fraction because one's odd, one's even, nothing adds up to 3 or to a number that is divisible by 3, so I can't do that. And I also know that 7 is what we call a prime number. The only things that will multiply together to make 7 are 1 and 7. Okay, so 7 is a prime number, meaning I cannot reduce this fraction. So I'm going to go ahead and start with our division bracket here. Which number goes on the inside and which one goes on the outside? Remember, the top one always goes on the inside and the bottom always goes outside. So can 8 go into 7? Well, no, it can't. So I'm going to add a decimal and a 0. Don't forget to add your decimal here. Can 8 go into 70? Yeah, 8 goes into 70 8 times because 8 times 8 is 64. Now 70 minus 64 is 6. Okay, so we didn't get a remainder of 0, so we have to keep going. So I'm going to add a 0 and bring that down. Can 8 go into 60? Yes, it can. 8 times 7 is 56. So now I'm going to subtract that. 60 minus 56 is 4. Okay, so we're still not done. Our fraction, or our decimal hasn't repeated, and we still have a remainder. So we're going to add another 0 and keep on going. Can 8 go into 40? Yes, it can. 8 times 5 is 40. So there is no remainder. So that means that this fraction now ends. Now, our answer isn't just 0.875. Remember, we had that 1. So I'm going to write my answer as 1.875. Okay, moving on to number 10. So we have 7 over 12. I cannot reduce this fraction, so I'm going to go ahead and start with my long division. Oops, I don't know what happened there. There we go. Okay, so remember which number goes on the inside. The number on top always goes on the inside, so there's my 7, and my 12 is going on the outside. Now 12 cannot go into 7, so I'm going to add a decimal and a 0, and I'm going to put my decimal in my quotient line. 12 goes into 70. It does go into 70. It goes in 5 times. 12 times 5 is going to be 60. 70 minus 60 is 10, and I'm going to add a 0 and bring that down. How many times does 12 go into 100? Well, 12 times 8 is 96. 100 minus 96 is 4. So I'm going to add a 0 and bring that down because we're not done. How many times does 12 go into 40? Well, 12 goes into 40 3 times. 3 times 12 is 36. And 40 minus 36 gives me 4. Okay, let's keep going. I'm going to add a 0 and bring that down. How many times does 12 go into 40? Well, it goes in 3 times. 3 times 12 is 36, and I get 4. Okay, are you seeing what's going to happen if I add another 0 and bring that down? I'm going to have 40 again. Am I ever going to have any digit for the rest of this fraction that's anything but 3? No. That 3 will continue to repeat over and over and over again. So this fraction does not end, but it does repeat. And the way that we're going to write this is we're going to write it as 0.583, and we're going to put a bar over that 3. What that bar indicates is that that 3 repeats forever and ever and ever. So this fraction does not end, but it does repeat. Okay, moving on to the next page. How to recognize if a decimal will repeat or terminate. Okay, so step 1 is to reduce the fraction to simplest form. Always, always, always reduce your fractions. Step 2 is to look at the denominator. If you have a multiple of 3 or 7, that decimal will repeat. However, if you have a multiple of something else, that decimal will terminate or end. Oops. Okay, so let's look at some of these examples here. So number 11, I have 8 over 9. Okay, so 8 over 9, I look at my denominator here, 9. It is a multiple of 3. 3 divides into that evenly. Okay, so I know that I'm going to have a repeating decimal, but let's prove that using long division. So we're going to make our division bracket. Remember, our top number goes inside and our bottom number goes outside. 9 can't go into 8, so I'm going to add a decimal and a 0. How many times does 9 go into 80? Well, 9 goes into 80 8 times. 8 times 9 is 72. 80 minus 72 gives me 8. Well, I'm going to add a 0 and bring that down. How many times does 9 go into 80? 9 goes into 80 8 times. 8 times 9 is 72. 80 minus 72 is 8. Do you see the pattern that I'm going to see here? I know that that 8 is going to continue to repeat. So I know that 8 ninths is equivalent to 0.8 repeating. So I put a bar over that 8. Okay, let's look at the same thing right here. 2 over 9, 2/9. Well, my denominator, as we've pointed out, is a multiple of 3. 3 goes into 9 3 times. So I know I'm going to have a repeating decimal. So let's go ahead and use long division. So my division bracket here, I know that my top number goes inside and my bottom number goes outside. So can 9 go into 2? Nope, it cannot go into 2. I'm going to add a decimal and a 0. Can 9 go into 20? Yeah, it goes into 22 times. 2 times 9 is 18. 20 minus 18 is 2. Add a 0 and bring that down. Can 9 go into 20? Yes, it can. It can go in twice. 2 times 9 is 18. 20 minus 18 is 2. Do you see the pattern here? That 2 will continue to repeat. So 2/9 is equivalent to 0.2 repeating. Okay, now I do want you to look at 8/9 is equivalent to 0.8 repeating, and 2/9 is equivalent to 0.2 repeating. Do you kind of see a pattern there? Do you see how our answer resembles our numerator, our top number? So without having to do really any work, could you figure out what 4/9 would be if it was written as a decimal? If you say it would be 0.4 repeating, you are correct. Remember, that decimal is going to match the numerator. Okay, let's look at number 14. So this time we have 8 over 11. So I can't reduce this fraction. And I notice that my denominator is not a multiple of 3 or of 7, but I'm going to teach you a trick. I can make this denominator a multiple of 3. So here's how I'm going to do that. I'm going to change it from 11 to 99. The way I do that is I multiply times 9. And if I do that on the top, I have to do that on the bottom. Okay? So now I'm going to have 8 times 9 is 72. And 11 times 9 is 99. So I'm going to tell you that just like what we saw when our denominator was 9, I know that I can write this as a decimal with 72, our numerator, repeating. So 0.72 repeating. Now I want to show you that if I were to use long division, I would have gotten the exact same thing. Okay, so the way I'm going to show that to you is I'm going to erase all of that, and I'm going to do it the old-fashioned way. So I can't reduce this, so I'm going to divide. And I know my numerator goes inside, my denominator outside. 11 goes into 8 how many times? Well, it can't go into 8, so I'm going to add a decimal and a 0. Okay, how many times does 11 go into 80? 11 goes into 80 7 times. 11 times 7 is 77. I'm going to subtract that, and I'm going to get 3. So I'm going to add a 0 and bring that down. How many times does 11 go into 30? Well, it goes into 30 2 times. 2 times 11 is 22. 30 minus 22 gives me 8. I'm going to add a 0 and bring that down. How many times does 11 go into 80? Well, 11 goes into 80 7 times. 7 times 11 is 77. Subtract. You get 3. I'm going to add a 0 and bring that down. How many times does 11 go into 30? It goes into 32 times. 11 times 2, 22. And are you seeing the pattern here? It will keep repeating. So I know that this fraction is equivalent to 0.72 repeating. So remember that trick that we just showed. So if I have this fraction, if I have this fraction here, this fraction here, I can multiply by 9 on the top and 9 on the bottom. And I get 72 over 99. So my trick was that this right here will be what repeats in my fraction. So 0.72 repeating. Okay, let's look at number 15. Can we use that same trick? Yes, we can. So if I multiply times 9 here and times 9 here, I end up with 27 over 99. So what would be our decimal equivalent? Hopefully you said 0.27 repeating, and that would be correct. Okay, now number 16. So we have 7 over 18. So here's what I know. My denominator here is a multiple of 3. 3 goes into that 6 times. So I'm expecting this to repeat. I don't have any great tricks for this one, so we're going to do it the old-fashioned way. So we have our division bracket here. We know that our numerator goes inside and our denominator outside. So 18 does not go into 7, so I'm adding a decimal into 0. 18 does go into 70. So I know that 18 times 1 is 18. 18 times 2 is going to be 36. So let's try 18 times 3. 3 times 8 is 24. 3 times 1 is 3 plus 2 is 5. So I get 54. Okay, so now 70 minus 54. So I know that I could make that a 6 and make this a 10. So 10 minus 4 is 6. 6 minus 5 is 1. So I get 16. So I'm going to add a 0 and bring that down. How many times will 18 go into 160? Well, I know that 18 times 10 is 180. So it's either going to be 9 or 8 times. Let's start with maybe 8 times. So 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. So I get 144. Okay? So now we need to subtract. So I'm going to make this a 5 and this a 10. So 10 minus 4 is 6, and 5 minus 4 is 1. Okay, so I still have 16, so I'm add a 0 and bring that down. And notice I'm back to 160. We were just at 160 right there. Now we're back to 160. So how many times will 18 go into 160? Well, it would go in 8 times. Okay, so what's going to happen to that 8? That 8's going to repeat and continue to repeat. So 7 over 18 is equivalent to 0.38. And that 8 is the only digit that repeats. Okay, number 17, 3 over 20. I cannot reduce this, so I'm going to have to just start with long division the old-fashioned way. Remember, the number on the top goes inside, the number on the bottom goes outside. Now, can 20 go into 3? Nope, it can't, so add a decimal and a 0. Can 20 go into 30? Yep, it sure can. It can go in one time. 1 times 20 is 20. 30 minus 20 is 10. Okay, so I need to add a 0 and bring that down. How many times can 20 go into 100? Well, 20 goes into 100 5 times. 5 times 20 is 100. So there is no remainder. So because I have a 0 here, this decimal ends. So 3 over 20 is equivalent to 0.15 or 15 hundredths. And finally, number 18. So I do want to teach you a little trick with this one. So we see how our denominator is 50, right? Well, 50 times 2 would make 100. Oops. And I could multiply our top by 2 as well. So if I do that, I would get 86 over 100. Well, how do I write that as a decimal? Wouldn't I write that as a decimal as 86 hundredths? Just like that? Well, I sure would. Let's see if I use my long division, if that's the same answer that I get. So we have our division bracket here. My numerator goes on the inside and my denominator on the outside. Can 50 go into 43? Nope, it cannot. So I'm going to add a decimal and a 0. Well, can 50 go into 430? It sure can. I know that 5 times 9 is 45, so I'm going to start with 8. 8 times 5 is 40, and I'm going to add a 0, so 400. When I subtract, I get 30, so I'm going to add a 0 and bring that down. Can 50 go into 300? It sure can. 5 times 6 is 30, so we have 300 for 50 times 6. 300 minus 300 is 0, so this decimal ends. So we have 0.86. Notice we have the exact same answer. Okay, and thinking about that, would I have been able to use a trick like that for this one here? Let's think on it. So we have 3 over 20. What would I have to multiply 20 by to get to 100? If you said 5, you're correct. I would multiply 20 times 5 to get to 100. I would also have to multiply this 3. So 3 times 5 is 15. 20 times 5 is 100. So to represent this right here as a decimal, I would write it as 0.15, 15 hundredths. Now, is that the same thing that we got up here? It sure is. So that trick would work there too. So if you have a denominator that you can make 100, you can easily write your fraction. Okay, that is the end of our extra notes. If you have any questions, just let me know. Y'all have a great day. Bye.